Right now, if you dropped straight down through the ocean above your head, you'd lose the sun before you even ran out of things to be afraid of. Not gradually, not like a sunset. By the time you passed 1,000 meters, you'd be in a place so dark that human eyes have never adapted to seeing it. Not once in the entire history of our species. And yet, somehow, most of the ocean's water sits below that line. So where does all the light actually go? It starts simple. Even at just 1 meter underwater, you've already lost more than half the sunlight that hit the surface. Water isn't clear the way air is. It's constantly absorbing light, converting it into heat, one photon at a time. The deeper you go, the more water is stacked above you, and the more light gets swallowed before it ever reaches you. But here's where things get strange. Light doesn't disappear all at once, and it doesn't disappear evenly. Red light, the longest wavelength visible to us, vanishes first, usually within the first few meters. Then orange, then yellow. One by one, the colors of the rainbow get filtered out with depth, like the ocean is slowly stripping away a spectrum. By around 200 meters, you've entered what oceanographers call the twilight zone, and almost everything down there looks the same eerie shade of blue, because blue is the last wavelength strong enough to survive the trip. Researchers at institutions like Woods Hole Oceanographic Institution describe this twilight zone as a layer that stretches around the entire planet, sitting roughly between 200 and 1,000 meters down. There's technically still light here, but nowhere near enough for photosynthesis to work. Plants and algae that depend on sunlight simply can't survive at this depth. It's a strange in-between world, too dark to grow anything, too bright to call it truly black. That changes below 1,000 meters. This is the boundary scientists call the midnight zone, and the name isn't exaggeration. Beyond this point, sunlight is functionally zero. Not dim, not faint. Zero. Any light down here comes from something else entirely. Bioluminescence. Chemical light produced by the animals themselves, which is why so many deep-sea creatures glow, flash, or pulse in the dark. In a world with no sun at all, making your own light becomes one of the only ways to see, hunt, or attract a mate. Except there's one problem scientists are only beginning to understand. The ocean isn't just naturally dark below a certain depth. In some regions, it's getting darker, even near the surface. A 2025 study analyzing 2 decades of satellite data found that light penetration has measurably decreased across large stretches of the global ocean, in some areas by more than 50 meters of usable depth. That means the sunlit zone, the thin slice of ocean where 90% of marine life depends on light to survive, is quietly shrinking in places, driven by changes in water clarity from nutrients, sediment, and shifting ocean circulation. Here's why that matters more than it sounds like it should. Almost every food web in the ocean starts with light. Phytoplankton need it to photosynthesize. Small fish eat the phytoplankton, bigger fish eat those. If the usable light layer gets thinner, that entire chain gets compressed into a smaller space, and scientists genuinely don't know yet what that means for fisheries, for carbon cycling, or for the animals that migrate up from the twilight zone every night to feed near the surface. One of the largest migrations of biomass on the entire planet happening every single day, mostly unnoticed. So here's the full picture. The ocean doesn't go dark because there's nothing left to see. It goes dark because light itself has limits, swallowed wavelength by wavelength until nothing survives the descent. And in a world with almost no light at all, evolution simply built its own. The ocean isn't empty, it's simply waiting for us to discover what's still hiding below. If you enjoy exploring the unknown, there's plenty more waiting beneath the surface.